Right now, as you watch this video, every single human being who has ever lived, every king and peasant, every scientist and soldier, every child who ever looked up at the night sky and wondered, they all lived and died on one single rock, one planet, one fragile, beautiful, vulnerable rock, hurtling through a universe that does not care whether we survive. But that is about to change, because humanity is going back to the moon. And this time, we are not leaving. This isn't just about flags and footprints. This is about survival. This is about turning our moon, that pale, silent guardian we've stared at for 100,000 years, into the greatest launchpad civilization has ever built. Today, we're going to break down exactly how we do it, step by step, mission by mission, because the plan is already in motion, and it is extraordinary. Before we talk about what the moon gives us, we need to understand why Earth alone is a dead end. Our planet has survived 5 mass extinction events: asteroid impacts, volcanic winters, ice ages that buried continents. Each time, life scraped by, barely. And here's the uncomfortable truth that scientists, philosophers, and even billionaires are beginning to say out loud. It's not a matter of if something catastrophic threatens Earth again. It's a matter of when. But let's set aside the doomsday framing for a moment, because the case for the moon isn't just about fear. It's about ambition. The moon sits roughly 239,000 miles from Earth, close enough to reach in about 3 days with current technology. In cosmic terms, it is basically our backyard. And that proximity is everything, because launching anything from Earth's surface is brutally expensive. Earth's gravity is a trap. Every pound of fuel, every piece of equipment, every human being we want to send into deep space has to fight its way out of a gravitational well that demands enormous energy. The moon's gravity is only 1/6 of Earth's. Launching from the moon costs a fraction of what it costs from Earth. That changes the entire math of space exploration. Think of it this way. Earth is the harbor. The moon is the dock. And from the dock, you can reach anywhere in the solar system. But to build that dock, we need to understand exactly what the moon has to offer. And what it has to offer will genuinely shock you. For decades, we thought the moon was bone dry. A dead, dusty wasteland with nothing to offer but rocks and regolith. Then we found water. In 2009, NASA's El-Cross mission deliberately crashed a rocket into a permanently shadowed crater near the moon's south pole, and the plume of debris it kicked up contained water ice. Since then, multiple missions have confirmed it. Billions of pounds of water ice are locked inside craters that never see sunlight, craters so deep and so cold that they've been frozen in darkness for billions of years. Now here's why that is a civilization-changing discovery. Water is not just for drinking. When you split water molecules apart through a process called electrolysis, you get hydrogen and oxygen. Hydrogen and oxygen are rocket fuel, meaning the moon's south pole is sitting on top of a natural gas station, one that can refuel spacecraft heading not just back to Earth but outward, to Mars, to the asteroid belt, to Jupiter's moons. Every future deep space mission becomes dramatically cheaper and more feasible if it can stop at the moon, mine water, convert it to fuel, and continue onward rather than carrying all of that fuel from Earth's surface. This is why NASA's Artemis program is specifically targeting the lunar South Pole. This is why China's Lunar program is targeting the same region. There is a reason multiple spacefaring nations are in a quiet race to that part of the moon, and it has everything to do with water. The nation, or the company, that controls the South Pole's water ice controls the future of the inner solar system. Water is just the beginning. The moon is rich in a mineral called ilmenite, which contains both iron and titanium, 2 of the most useful structural metals in engineering. It has silicon in abundance, the core ingredient of solar panels. And locked in the lunar soil, delivered over billions of years by the solar wind, is an isotope called helium-3. Helium-3 is rare on Earth to the point of near non-existence. But on the moon, it exists in quantities that some physicists believe could power human civilization for thousands of years, if we ever crack commercial nuclear fusion. The moon may literally be sitting on the energy source that ends our dependence on fossil fuels forever. But even before we get to the exotic stuff, the practical mining applications are staggering. The lunar regolith, that fine grey powder covering the moon's surface, can be processed through a technique called in situ resource utilization, or ISRU. Using heat and chemistry, we can extract oxygen from the soil itself. We can 3D print structures using regolith as raw material. We can build roads, landing pads, radiation shelters, and eventually entire habitats, not by shipping materials from Earth, but by using what the moon already provides. This is the philosophical shift that makes everything else possible. The moment we stop treating space as a destination we visit and start treating it as an environment we harvest, the economics of becoming multiplanetary flip entirely. Earth stops being the sole manufacturer of everything we need. The moon becomes our first off-world industrial base, and from there, the model replicates outward, to Mars, to the asteroids, to wherever humanity chooses to go next. Now let's talk about infrastructure. NASA, in partnership with the European Space Agency, the Japanese Aerospace Exploration Agency, and others, is building something called the Lunar Gateway. It is a small space station, not in Earth's orbit like the International Space Station, but in lunar orbit, a permanent outpost circling the moon. The Gateway is designed to serve several critical functions. It is a staging point for missions down to the lunar surface. It is a laboratory for long-duration spaceflight research. It is a communications hub. And most importantly, it is a waypoint, a jumping-off point for missions heading deeper into the solar system. Think of the Gateway as humanity's first deep spaceport. Ships can dock there, crews can transfer, supplies can be stored. If we're launching a crewed mission to Mars, the Gateway is where you assemble the vessel, top off the tanks with fuel refined from lunar water, and begin the long journey outward. This is not science fiction. Construction of the Gateway's first modules is already underway. The timeline targets lunar orbital operations within this decade. Combined with the Artemis program's goal of establishing a sustained human presence on the lunar surface with habitats, power systems, and rovers, the picture becomes clear. Within a generation, the moon will not be a place we visit. It will be a place we live and work. And everything built there, every lesson learned, every system tested in the harsh environment of the moon, it all applies directly to the next destination. Here is the part of this story that doesn't get talked about enough. Mars is hard, brutally, almost incomprehensibly hard. It is, on average, 140 million miles away. A one-way trip takes 6 to 9 months. The atmosphere is 95% carbon dioxide and so thin it offers almost no protection from radiation. Temperatures swing from -220 degrees Fahrenheit at the poles to a comparatively balmy -20 near the equator in summer. A global dust storm can last for months, blotting out the sun and killing solar power. If something goes wrong on Mars, you cannot call for help and have it arrive any time soon. The communication delay alone, caused by the speed of light across that distance, can be anywhere from 3 to 22 minutes each way. There is no rescue mission that arrives in days. On Mars, you are on your own. The moon lets us practice being on our own, from 3 days away instead of 9 months. Every habitat design we test on the moon informs what we build on Mars. Every medical emergency handled in a lunar outpost teaches us how to train astronauts for true long-duration isolation. Every crop grown under a pressurized dome, every EVA suit stressed against vacuum and abrasion, every autonomous robot that learns to navigate rough terrain without real-time instruction from Earth, all of it is a rehearsal. The moon is the dress rehearsal before opening night, and opening night is Mars. When Elon Musk and SpaceX talk about a self-sustaining city on Mars, when NASA lays out a roadmap to a crewed Mars landing, none of those visions are possible without the moon. Not because of politics or funding, but because of physics and engineering reality. The moon is where we earn the right to go to Mars. Let's be real for a moment, because space timelines have a long history of slipping. So let's look at what is actually happening, right now, today. The Artemis program has already launched the Orion spacecraft on an uncrewed lunar flyby and return mission, proving the hardware works. A crewed lunar flyby is planned for the near future, and a crewed landing at the South Pole follows after that. The first humans on the moon since Apollo 17 in 1972, and this time one of them will be a woman, and one will be a person of color. SpaceX's Starship, the largest and most powerful rocket ever built, has been conducting test flights and is under contract with NASA as the human landing system for Artemis. Starship is also designed for full reusability, which is the key to making spaceflight economical at the scale required for colonization. China has announced a joint lunar base project with Russia, targeting the lunar South Pole with a permanent robotic and eventually human presence before 2040. The competition is real, and historically, competition accelerates timelines dramatically. Private companies are active too. Intuitive Machines has already successfully soft-landed a commercial spacecraft on the moon. Astrobotic is developing lunar delivery services. A dozen other companies are working on everything from lunar rovers to resource extraction equipment to communication satellites in lunar orbit. The pieces are assembling, the funding is flowing, the rockets are flying. This is not a future dream, it is the present reality, moving faster than most people realize. Let's zoom out one final time. There is a version of the future where the things we are building on the moon remain the exclusive domain of governments and billionaires, a scientific enterprise disconnected from the daily lives of ordinary people. But there is another version, and I believe it is the more likely one. The technologies being developed for lunar survival, water recycling systems, closed-loop agriculture, miniaturized nuclear reactors, advanced medical diagnostics for remote environments, every single one of those technologies has applications here on Earth. In drought-stricken regions that need clean water, in remote communities that need reliable power, in hospitals that need better diagnostic tools. The space race didn't just give us the moon, it gave us memory foam and water filtration and the miniaturized integrated circuits that became the computers in your pocket. The return on investment from space exploration, measured in earthbound technological spillovers, is historically enormous. And beyond the practical, there is something profound about what it means to be a species that does not put all of its eggs in one basket, that chooses expansion over stagnation. That looks at the incomprehensible vastness of the universe and says, we want to be part of that. Every generation has had its defining challenge, its great mountain to climb, its great ocean to cross. Ours is the solar system, the moon is the first step, and the first step, as someone once said, is the one that matters most. Sometime in the next decade, maybe sooner, a human being is going to stand on the south pole of the moon, look up at a marble-sized Earth hanging in a black sky, and take a breath of air recycled from lunar ice. That person will be the first link in a chain, the chain that leads to a permanent lunar base, to a fueling depot that sends ships to Mars, to a small, cold, red world where humans will be born who have never in their lives breathed Earth's air or felt Earth's gravity. A new branch of the human family, growing in a new place, carrying our stories, our music, our curiosity, and our stubborn refusal to accept that this one planet is all we get. We are a species that crossed oceans we couldn't see the far side of. We are a species that climbed mountains just to know what was at the top. We are a species that, in 1969, pointed at the moon that had watched us from the beginning, and said, we're going there. We are going back. And this time, the journey doesn't end when we plant a flag. This time, the journey is just beginning. If this video got you thinking about where we're headed as a species, drop a comment below. I want to know, do you think humanity will have a permanent moon base within your lifetime? And if you haven't already, subscribe, because this story is nowhere near over.